Hi everyone, welcome back to another AP Calculus video. Today we're going to talk a little bit more about that definite integral and some properties that go along with it. And so I call this part one of a two-part series, and in part one we're going to do the frequently asked questions, the Integration 101 FAQ. So question number one. First of all, let's review what an integral looks like. So a definite integral goes like this. We have our limits of integration. Those are my a and my b. We have our function. This is often called the integrand. And then we have dx wrapping it up in the end. So question number one deals with reversing the limits of integration. So if I have an integral that goes from a to b, and it's going to equal out to be some number. If I switch the limits and go from b to a, suppose I get them backwards, what's going to happen is I'm going to get the same number, but it's going to be negative. And so the way that we write this, the property that we're writing here with these limits of integration, the way that we're going to express this is this. When I switch the limits of integration, I just put a negative sign. So you get the opposite answer. So if from a to b the area is 5, from b to a the area is -5. And it just has to do with the direction that we're traveling along that x-axis. So that's question number one. If we switch the limits of integration, we switch the sign of our answer. Now, question number two. What happens if both limits are the same number? So in this case, we integrate from a to a. Let's try that again. We integrate from a to a. I have to get my hands to do what my brain and my mouth are saying. When you are integrating from the same number, let's think about this. The idea is we have a function, and if this is a, we're integrating a slice from a to itself. It has no area. It's a one-dimensional slice. So anytime we integrate from a number to itself, the area underneath is always going to be 0. It has nothing. It's 0. What happens if there's a constant I want to multiply by or factor out? So like, for example, if I have a, and I like writing down my examples over here. We'll do a numerical example. So if I end up integrating from a to b are any arbitrary numbers, and I have 3x squared plus 6x. Notice I can factor out a constant. So if you can factor a 3 out, here's the cool part. The 3, just like when we deal with derivatives, the 3 in an integral won't have anything to do with your final answer. So you can actually take a constant and move it to the outside and treat it like this: 3 times the integral of a to b of this simpler equation. So you can actually factor out a constant. The same thing works if you want to multiply it through. So constants can be factored out or multiplied through. And here's the notation that we would write. So if you have an integral from a to b, some constant c times your function. So here's c, here's f of x. When we talk about, what it looks like over here in real life, you can take that constant and move it to the outside. And then you just multiply it at the end. That's really nice because later on we're going to be dealing with finding some integrals of things involving pi. Oof. And pi is always easier to factor out in these problems. This is in chapter 7. So this is a really great property that we need to kind of keep in mind. We can factor things out of integrals. Number 4, how do I integrate something with two functions that are added or subtracted? Great question. So that would look like this. If you are integrating and you have f of x plus g of x, you can split the integral into two, a to b of f of x dx, so you can integrate them separately. And that's what that rule looks like. I'm going to get rid of this now that we're done talking about it. And the same thing happens if we're subtracted, so it doesn't matter if it's plus or minus. So plus or minus, it doesn't matter. You can split them up. And this is what allows us to do what we call term-by-term integration. So at some point here in the near future, we're going to be learning how to integrate things like sine of x plus ln of x or something crazy like that. right? So we can split them up and just do the integral of sine of x and then add it with the integral of natural log of x, whatever that happens to be. So this would be like your f of x and your g of x. Okay, so term by term integration, especially when we have little mini functions as our terms. So question 5, how do I integrate two functions that are multiplied or divided? Here's the deal. You can't yet. This is a BC topic. And the reason it's a BC topic is simply because, well, and actually the division part may not be BC. Some of them we'll be able to do with something called U substitution. And then some of it we're going to have to use a different way to go about it called integration by parts, which is a BC topic. And it's something we're going to learn in Chapter 6. So Chapter 6, and then some of them you'll have to use BC. You'll have to come take Calculus BC to learn some of the other integration techniques. But you can't do these yet. So one of the really common questions that you'll see is, hey, if you have like an integral of f of x times g of x, is there any way to evaluate that? And the answer is no. You can't do anything like that yet. Question 6, what if I have two integrals of the same function, but they integrate at different spots? So like, for example, let's say you're integrating something from a to b, and then you have from b to c the same function. What happens when we combine them? Well, this happens. You get the integral from a to c. So the idea here is, you're going from a to b. So here's your picture, right? It should make sense. So if this is a, and this is b, and this is c, well, if the integral from a to b is this area, and the integral from b to c is this area, well, then it should make sense that this area will be the combination of those two areas together. So you can split your integrals up, which is a really important thing to remember, because coming soon, that's gonna be the only way that we evaluate some of these integrals that we come across. So let's practice a little bit with some of the stuff we know here. And again, this video is part 1 of 2. So in this video, we're just exploring these properties. In part 2, you're actually going to learn some integration techniques, and it's going to be kind of cool. So here we go. I'm going to give you two different functions. We have f of x and we have h of x. I know that the integral from -1 to 1 for f is 5, and from 1 to 4 is -2. And then I know a little bit about h of x. From -1 to 1, h of x, the integral is 7. So if possible, find this information. So f of x, let's highlight these in green. So this is an f of x problem, so I'm going to be using those green little bits up there. Here, I want to find the integral from 4 to 1. Well, that's great. I know that from 1 to 4, the area is -2. So if I reverse those limits of integration, all I'm going to have to do is realize that, oh, this is this property. It's the opposite. So it's going to be -2 or +2. The next one wants me to find the integral from -1 to 4, so it's an f of x problem. Now I have 1 to 4, and I have -1 to 1. So what I'm going to have to do is I'm going to have to combine those up and realize that this integral, to go from -1 to 4, I'm going to have to take -1 to 1 and add to it 1 to 4. That'll give me -1 to 4. So I'm going to take the two numbers up here, 5 and -2, and add them together. And I'm going to get 3. Now, for some of these problems, I like to use the little s with the limits just to help me understand what's happening. So this is kind of my work and my shorthand, and I think it's okay if this is something you do off on the side of your paper. Just be aware that if you don't use proper notation in a free response type question, you could get penalized for having this work as part of your official explanation. So off on the side, sure, scribble it in. If you're doing multiple choice, sure, scribble it in. But make sure that you're using proper notation on a free response question. The next one asks me to find 2 f of x plus 3 h of x. from -1 to 1. So that's great. I know -1 to 1, f of x is 5, and then h of x is 7. So here's where I'm going to use that constant, because I'm going to remember that this, I can pull the 2 out, and then I can also split these up into 2 different term-by-term integration scenarios. So I'm doing 2 of the properties that we talked about up there. And now I'm going to go ahead up there and I'm going to pull out the f and the h. So this is 2, this integral is 5, and then 3 times 7. Okay, so 10 plus 21 is 31. Easy peasy. That's all I'm doing. I'm using that constant. I'm factoring out the constant, bringing it outside of the integral, and then splitting it up into 2 different integrals for each function. So 2 functions added together in the same integral can be split up. And then here's my trick question, right? Can't do it yet. Eventually there will come a time when we can attack these integrals that are multiplied. We just don't know enough yet. But we can add and subtract them. So this has been a little summary of the rules and the frequently asked questions and the basics of how integrals work and their properties. So hopefully this has been nice and helpful. This is only part 1, so make sure that you go on and watch part 2. And just remember, stick with it. It might seem like a lot right now, but you can do it. You've got this.